So in this video, we're going to simplify, use an application property of exponents. So say I've got 5 to the 4th over 5 to the 6th, okay? So whenever I work through this problem, you can use your rules. Your rules say exponents, okay, same base. Division, we divide, we're subtracting our exponents, so that's 5 to the 4 minus 6. Okay, gives me 5 to the negative 2. Well, what do I know about negative exponents here? All right, so I can't have a negative exponent, so in order to get rid of that, I have to do the reciprocal, and this becomes 1 over 5 to, now it's the positive 2 there. Okay, so it becomes positive whenever I flip it. Now, 5 squared, we can do that real quick. 5 times 5 is 25. So this is 1 divided by 25 is my final answer. That's what they're looking for. That's simplified. Okay? Now, if you wanted to do this where you just wrote it out, you could. What I mean by that, you could write 4 5s up top and 6 5s down low. Okay, and then what do you see happens? Well, 5 cancels the 5, 5 and the 5, 5 and the 5, 5 and the 5, and up top I have a 1 left, and in the denominator I have 2 5s, which make 25. So you get the same answer either way, whether you want to use the formula way or you want to just muscle it out. Okay? Say now instead I'm going to mix some variables together. So n to the 5, y to the 4th, divide by n cubed, y to the 11th. All right. Now, x's only cancel with x's, y's only cancel with y's, n's only cancel with n's, okay? So how many n's do I have up top? I have 5. How many do I have down low? I got 3. And then with y's, I have 4 up top and 11 down low. So with the n's, okay, there's 5 up top, 3 down low. Who's going to win that fight? There's going to be 2 n's up top that win, okay? So there's 2 more n's up top than there are down low. Now, in the denominator, who's going to win this one? Well, it's going to be y to the 4th up top and y to 11 down low. Well, I think 11 y's are going to beat 4 y's all day. Now, how many is it going to win by? It wins by 7. So 11 minus 4 gets you 7. So there's y to the 7 down low here. So if you want to do it by the rule way, the rule, okay, if I did n to the 5th, y to the 4th over n cubed, y to the 11th, how the rule would look like is this. I'd write n, and then what would I do? I'd do 5 minus 3, and then I'd have y, and what would I do for my exponent? I'd do 4 minus 11. And when I simplify, I get n squared, y to the negative 7. But we can't have negative exponents. They can only be positive. So this n here is good, but this n to the negative 7 we got to fix. So how do we fix that? We have to do the reciprocal 1 over y to, now it's the positive 7. And so whenever I multiply, I get n to the 2 over y to the 7, which is what I got here with my other way of thinking about it. So whichever way, you find you like more, to me, I like to think of it kind of like a game. If I've got 5 n's up top and 3 n's down low, obviously these 3 n's up top take out those 3 down low. And so that means that the top wins by 2. And so I have n squared on top. And then same thing with the y's. If I only have 4 up top, but I have 11 y's down low, and guess what? Those 4 cancel with those, but I'm left with 7 y's down low. Okay? So that's kind of how I think about it. However you want, if you want to use the rule, fine by me. Okay? So let's say x cubed raised to the negative 5. Now, how do I do this? This is a power to a power. Now, I don't really know how to write this negative 5 times, so I kind of have to use my rule here. So the rule says when I have a power to a power, I'm going to multiply the exponents. So if x to the 3 times negative 5, 3 times negative 5 gets me negative 15. And so to fix this to be a positive exponent, I do the reciprocal, flip it downstairs. I have x to the positive 15 here. Okay? Let's try this one. 2x to the negative 3, negative 2 equals, now, once again, power to the powers, right? The question is, what is the exponent on that stinking 2 right there? Well, you always ask yourself, when you're thinking about exponents, you're thinking, how many are there? Well, when I look at this, I only see 1, 2, so it's an understood 1 for my exponent. There's only 1. There is only 1, 2, okay? So when I multiply, what do I get? I get 2 raised to the negative 2 multiplied by x raised to the negative 2 times negative 3, right? And so what happens? I get 2 to the negative 2 multiplied, a negative and a negative make a positive x to the 6. Now, 2 to the negative 2, I've got to do the reciprocal. That's 1 over 2 to the 2, x to the 6. We're almost simplified. 2 to the 2 is 4, so the 1 over 4, x to the 6. So 1/4 x to the 6. Okay, that's what I'm looking for right there. Okay, what if I have 1 over negative 3 x to the negative 6? Yikes. All right. So when I look at this problem, I'm looking, okay, negative exponents. All right, so I see a negative exponent here, but it's in the denominator. Well, how do I do this? I do the reciprocal of what's in the denominator. So if it's in the denominator, I got to flip it up to the numerator. So this becomes x to the positive 6 over negative 3. Now, how do I handle this negative 3? Whoa. Let's think about this for a second. We only do reciprocals on exponents that are negative, right? What is the exponent on this negative 3? The exponent, how many negative 3's are there? There's only one negative 3. So the exponent is a positive 1. So do we flip anything? No. This is our final answer. It's negative 1/3 x to the 6. Okay, that's it. All right, so don't, very common mistake, almost as common as negative 3 squared, right? So very common mistake. Oh my gosh. Mistake. Okay, don't do that. Now, let's try another one, see how good we are, see if we're progressing. 3 times m to the negative 1, n over m, n to the negative 2, all raised to the 2 here. Okay, so I'm going to work starting on the outside. How many do I have? I have to a power of 2. Okay, so you either write it out twice or you just go ahead and multiply. How many n's do I have in the numerator? I have 1. How many m's? Negative 1. How many 3's? Just 1. How many m's down here in the denominator? 1, and then negative 2. Okay, so there's a couple ways you can do it. You can actually go through and simplify the inside first if you want, or you can just multiply it out. Okay, so maybe we ought to just simplify on the inside first. Okay, so let's write this on the outside and let's do some cleaning up on the inside. It's a positive exponent, we leave it. That's a positive 3 to the 1. But this m to the negative 1 gets flipped downstairs to become m to the 1. Now this is a positive, so I'll leave it, so that's n to the 1 upstairs. Now I have an m to the 1 already downstairs, but then this needs to get flipped up to the numerator. And if I do that, that becomes n to the positive 2 upstairs. So now I can simplify. And so what do I have inside? I have 3 times, now I have 1n and 2n, so that's n and then nn. So, right? That's n raised to the 3. And then in the denominator, I have 2 m's. So m times m, that's m and m. Ooh, got jokes, right? M squared. And this is all raised to what power? It's raised to that 2 power right there. So what? So what's this going to be? This is going to be, well, I still have 1 there, so 2 times 1, so that's 3 raised to the 2. And then 3 times 2, so that's n to the 6. And then I divide by, well, this 2 and this m squared, that's going to be mm, which is m to the 4th, okay? Now 3 squared is 9, so I have 9 n to the 6, m to the 4th right there, and that's our final answer, okay? We'll do one more, and I think we'll be done with exponents. All right, z, you know what, let's do this. Bracket, parentheses, 3y to the negative 3, z to the 4th, close parentheses, squared, close brackets, negative 1. Oh my goodness. So maybe here it is an advantage to work from the inside out. Okay, so let's do this. Not only do we have a power to a power, we also have that power to another power. Okay? So when I look at this, there's only 1 3 in there. So when I multiply through, what am I going to have? I'm going to have 3 squared. I'm going to have y to the, now 2 times negative 3, that's negative 6. And then z to the 8. Okay, now I'm going to multiply this exponent times all these in here. 1, 2, 3. And so this is going to get me 3 to the negative 2. And then negative, negative make a positive. And then negative and positive make a negative. And I can simplify. First thing I'm going to do is get rid of those negative exponents by doing the reciprocal. So this is 1 over 3 squared, y to the 6, and then 1 over z to the 8. Now, that's equal to 1 over 9 times y to the 6. Y to the 6 you can write over 1 if you wanted to. Anything can be divided by 1. It's still itself. And then I have 1 over z to the 8. Now, whenever I multiply fractions, I multiply across the top, the numerator, and then I multiply across the bottom, the denominator. So 1 times y to the 6, that's y to the 6. And I have 9 times 1 times z to the 8th, that's 9 times z to the 8th, right there. And that, my friends, is the final answer. All right, hope we're good to go and you're able to work through those exponential or exponent simplification.